Okay, ladies and gentlemen, let's continue with what we were working on. Now, if we do number 3, we have this equation, or function rather, 3 to the power of x plus 2. Okay, so what is the base of our exponent? It's 3. It's greater than 1. Therefore, it's exponential growth. So we know which way the graph goes. So we make the little table. All right. So if x is 1, what happens to y? What do we get for y? So let's try it. So we get y equals to 3 to the power of 1 plus 2. What's 3 to the power of 1? Everybody, it's 3. Plus 2, it's 5. So when x is 1, 1 is 5. What if x is 0? So 3 to the power of 0 plus 2. What is anything to the power of 0? Again, we're going back to the last unit. Remember, anything to the power of 0 is 1. So 3 to the power of 0 is 1. 1 plus 2 is 3. Now, what if x is negative 1? So you get y equals to 3 to the power of negative 1 plus 2. Now, remember, if anything is to a negative power, how do we get rid of it? We switch it, flip it. So that will become 1 over 3 plus 2, which is 2 and 1/3. There we go. So we're going to graph these. Now we know the base is of your exponent is greater than 3, so it's exponential growth. So you go 1 and then 1, 2, 3, 4, 5. Then 0 and 3, that's our y-intercept. Remember, y-intercept is when x is 0. And then negative 1, 2 and 1/3. So 1, 2, and a little bit above 2, 2 and 1/3. I'm estimating here. So it's like this. Now, what is the asymptote? Where is the asymptote, I should say? Remember in the previous problem, the asymptote was the x-axis, right? Also, in the first problem that we did, asymptote was the x-axis. Now, what do we notice about these problems from 1 and 2? You see, in problem 1, there was nothing after this quantity. Same thing in problem 2. There's nothing after this quantity. But look at number 3. There is something, the number being added to this quantity. So, before we go any further on this problem, let me remind everybody about your h and k. So we can write a general function like this. Okay, if you guys remember when we were at school, h would cause the graph to move horizontally, right or left. K will cause the graph to move vertically, up or down. Okay, now it could be, if it's a minus value here, then the graph shifts down. If it's a positive value, the graph shifts up. So now let's look at our problem here, number 3. Look, there is no h, but, so that means that means the graph doesn't move horizontally. But look at this. This is your k. So that means the whole graph is shifted 2 units up. So I'm going to put a dashed line over there. What is that? That's our asymptote. So the asymptote for this function is no longer the x-axis, rather it's over here. So the equation of the asymptote, since it's a horizontal line, it's again y equals to a number. And what number is that? Whatever that is. Okay? Now if you go back to this problem, since there was no number here after this quantity, so it's 0, right? There is nothing here. So that's why it was y equals to 0, or the x-axis. Same thing in problem number 1. See? 2 to the power of x. There is nothing after. There's no plus or minus. It's a 0. So that's why the asymptote was again y equals to 0. Okay, so now we know that there is a k value, so that indicates where our new the asymptote is, y equals to 2. We know it's an exponential growth. My graphs are not the best, so it goes like that. So what are the key features? We have the table of values, we have the graph, we have the equation of the asymptote, and the asymptote itself as a dashed line. We can indicate the y-intercept, which is 0 and 3 as a point, and we write growth. Are we good? I hope so. All right. Now, I'm going to jump ahead to a few other problems and then come back. So let's take a look at number 6. Again, these are all from your Growth and Decay Review A. These are all from Growth and Decay Review A from your packet, which will be uploaded in Google Classroom by tomorrow. Okay, so let's jump to number 6. You have f of x equals to 5 to the power of negative x. Now, first of all, remember, you could be f of x, g of x, whatever, h of x. That doesn't matter. That means y. Now, is this exponential growth or decay? Well, if you just look at this, the base, you will see that it's a 5. And 5 is greater than 1, so you may conclude that it's an exponential growth. But you got to be careful, because there's a negative in front of the power, in front of the exponent. So that means we got to get rid of that negative exponent. So that means you got to flip this. Remember this rule of exponent? If you have a negative exponent, what do? We flip it. So actually, we have this. So you see, I took it to the denominator, the x became positive. So in another way of writing it, it would be like this. It's the same thing. 1 to the power of x is 1, and that's 5 to the x. So it's just another way of writing it. Now look at the base. Is that greater than 1 or between 0 and 1? Well, we know that 1/5 is between 0 and 1. 1/5 is between 0 and 1. Therefore, this is exponential decay. So anyways, we do the same thing again. 1, 0, negative 1. If x is 1, what's 1/5 to the power of 1? Anything to the power of 1 is itself, so we get 1/5. What's 1/5 to the power of 0 when x is 0? Anything to the power of 0 is, drum roll, anything to the power of 0 is 1. So we get a 1. What's 1/5 to the power of negative 1? So you have y equals 1/5 to the power of negative 1. So if you have a fraction with a negative exponent, how do we get rid of the negative exponent? You flip the fraction, the exponent becomes positive. So I have a fraction to the power of a negative exponent. So I'm going to flip the fraction, the exponent becomes positive. So what's 5 to the 1? Anything to the power of 1 is itself, so you get 5. So we know it's exponential growth. Oh, by the way, is there something after this quantity added or subtracted? No. So the asymptote is y equals to 0, because there is 0 here. There's nothing here. So again, it's the x-axis. Remember, y equals to 0. It's the same thing as the x-axis. If it's anything else over here, like our previous problem that we did, then we draw a dashed line. +2, -1, whatever it is, but we have 0 here. So that's our asymptote. Let's plot the points. So 1 and 1, that's +1, that's +1. So 1/5, again, I'm estimating is something around here. And 0 and 1, that's our y-intercept. -1 and 5. So we know it's exponential decay. Hey, I'm graphing okay. There you go. It comes very close to the asymptote, which is the x-axis, but it doesn't cross or touch it. That's the property of an asymptote. Okay, so what are the important features? We have the table of values, we have the graph, we have the equation of the asymptote, and we add the we add the y-intercept, which is 0 and 1, and we write the word decay. So these are the important features when you're doing this assignment, part B, review B. You got to add all of these things. Make sure you have a table of values. Make sure you have a good graph, very nice, legible graph. You have the equation of the asymptote, y-intercept, and decay or growth. Okay? All right. Let's move on to number 7. We're going to go for another 10 minutes or so, and then we'll stop. So I'm going to go a little faster. Okay, so what is my 2 here? 2 is my A. Remember the original equation? A times b to the power of x, right? So 2 is acting like my A, and b is my 3, the base of the exponent. That means this is what? Exponential growth, because 3 is larger than 1. Okay, again, same thing, make a table. 1, 0, -1. If we have 1 in place of x, what's 3 to the power of 1? 3. But what do we do with that 3? Because we have a 2 on the outside. 2 is being multiplied. So 3 to the power of 1 is 3. Well, let me write it down. So y equals to 2 times 3 to the power of 1. That's 3 times 2 gives you 6. Then 0 for x. What's 3 to the power of 0? Anything to the power of 0 is 1. 1 times 2 is 2. Then you have 2 times 3 to the power of -1. And remember, you cannot multiply the 2 by 3 because we have the order of operations. Please excuse my dear Aunt Sally. You got to take care of the exponents first and then multiply the result by the 2 outside. So don't multiply the 2 by 3. So now here we have 2 times 1/3, because we have a negative exponent, we flip it. 2 times 1, remember, you multiply straight across. You get 2 times 1 is 2, 1 times 3 is 3, so it's 2/3. Okay, and we know it's growth. And there is no number after this plus or minus, therefore the asymptote is again y equals to 0. And 1 and 6, 1, 2, 3, 4, 5, 6. 0 and 2, notice our y-intercept is not 0 and 1. It doesn't have to be all the time. And -1 and 2/3. Now 2/3 is almost 1, but is not. So it's close to 1, so I'm again estimating. So there you are. Oops, sorry, my graph doesn't come out though. So what are the important features? We've got the table, graph, equation of the asymptote, y-intercept, and the word growth. Or you can write exponential growth. Either one is acceptable for me. Okay? All right. Let's go back to number 4. This is growth and decay review A. Now, this is f of x equals to 0.21 to the power of x. Okay. Look at the base. Is that greater than 1 or between 0 and 1? It's between 0 and 1, so it's exponential decay. Again, you make your table, 1, 0, -1. So if 0.21 is raised to the power of 1, anything to the power of 1 is itself. What's 0.21 to the power of 0? Anything to the power of 0 is 1. Now I'm going to use my calculator. Remember, if you don't have a graphing calculator, that's okay. I don't know if you can see this. Okay, so we have 0.21 to the power of -1. It's 4.76. It's 4. You see, it's 4.76, or let's just round it off to 4.8. Okay, so it's exponential decay. We know that. And now we got to estimate a little bit. So we have, if that's 1, 0.21, this is 0.5, so 0.21 is about there, estimating. 0 and 1, that's our y-intercept. -1, so that's 1, 2, 3, I got a 4, 5, 1, 2, 3, 4, 5. 4.8 is very close to 5, so it's almost before 5. Oh, there's no number here, right? You don't see plus or minus here, so again, the y-intercept, I'm sorry, the asymptote, the equation of asymptote is y equals to 0. The asymptote is the x-axis. So we draw the graph, come very close to the asymptote, but don't cross or touch it. This is 0 and 1 for the y-intercept, and we write the word decay. Okay? I hope everybody's good. Number 5, we got a few more examples. Number 5, we got y equals to e to the power of x. What is e? Never seen it before. We'll get to that in the next video.